This is an excellent exposure of the Mather Gorge Formation here. You can actually see the original sedimentary layers here. This is the original bedding where this was deposited as thin sheets of silt and clay in fairly quiet water. There wasn't much current here. You can tell there wasn't much current because there's no cross bedding and the current has not eroded any of these layers. It's just deposited very, very quietly on the bottom of a fairly deep layer of water. The rock here also shows some very spectacular folding. You can see very clearly the thin beds of silt and clay, originally silt and clay, here in the Mather Gorge Formation, and they've been tightly folded so we can follow one individual bed up here all the way up to this point, and then it takes a hairpin turn. Technically this is called an isoclinal fold, and then it cuts back down on this side all the way down to the bottom here. A couple of wiggles here at the bottom, and then it follows all the way back with a couple of wiggles all the way back up here where it sort of disappears, but it'll come down the other side then. These tight folds indicate that this rock was very heavily deformed after the deposition of the sediment itself. I say that this was originally clay. There is no clay left in this rock now because this rock has been deeply buried and metamorphosed. It's a metamorphic rock now, and the clay has all gone to more coarse-grained, high-temperature silicates. This, on a very small scale, is exactly the same type of fold that you see on a very large scale farther down the river. We saw at the last outcrop that the granite cuts across these folds, although it wasn't all that clear at that point. So this folding was before the granite, and therefore it's before the 475 million year date that you get from the radioactive minerals in the granite. The Mather Gorge Formation, by the way, in an unrelated matter, is named for Mather Gorge, which is the gorge of the Potomac here at this point. And the existence of the gorge itself is of geological interest, much, much more recent geological interest than the rock. The rock here is almost over 500 million years old, very close to 500 million. The gorge itself dates back to the Ice Age, when the enormous quantities, volumes of water were tied up in the ice caps. Enough was tied up in the ice caps that sea level dropped 300 feet or so. The English Channel was dry at the time, and the people who came across during the ice ages were able to walk across the English Channel because there wasn't any water in it, because so much water was tied up in the ice. Now that had an effect locally here. When sea level dropped 300 feet, that allowed the rivers along the east side of the United States to cut down an extra few hundred feet into the edge of the hard rock at the edge of the continent. The Ice Age didn't last long enough to allow the rivers to cut all the way back, but close to the ocean, the rivers cut down. If you go farther back, on the other side of Great Falls, right here, the river doesn't have a gorge. Instead, it flows in a broad valley. So the gorge itself dates back to the Ice Age. The lower part of the gorge has now been covered up because the water has risen back up again and flooded the lower part of the Potomac Valley, making the estuary of the Potomac, which stops at Little Falls in Washington, D.C., which is why Washington, D.C. is there, by the way, because now ocean-going ships can make it all the way up to Alexandria and Georgetown, which are the old colonial ports on the river. At the time, the roads, that colonial days, roads in the colonies were absolutely miserable. Mud. There was no such thing as pavement. So if you wanted to ship things from, say, New York to somewhere in Maryland, you put it on a boat in New York, you brought it down by ship, and then brought it up as far on the rivers as you could. When the water became too shallow and you ran into rapids and falls, quote, little falls, unquote, you unloaded the ship, put it in a wagon, and then carried it the last few miles up those atrocious muddy roads to wherever they were going. You did that as little as possible. Therefore, a whole set of cities grew up right along the head of navigation of all these rivers, and that set the location of the original big cities on the East Coast. That particular line where you ran out of navigable water is called the Fall Line, and it marks the position now of US 1, which was built to connect all those big cities, and I-95. So I-95 location was actually determined geologically. But that's a completely different set of geology from these rocks here. It's a completely different topic, and I'll leave that at this point, and we'll go to our next stop.